Okay, everybody. So I was requested by a student to show you guys how to use the WebAssign graphing tool. So for instance, I have this problem from section 2.1, problem number 6, okay? And so when we're first given a function, we usually try to think about what function are we talking about. So for problem number 6, we're talking about linear functions. And one thing that we know from our linear functions is that if the function is written in point-intercept form, it will make it easier for us to graph. Now, you're probably wondering, what do I mean by that? So for instance, we have we have the linear function 9x plus 4y equals 16, right? Well, what I mean by point-intercept form, okay, is that y equals mx plus b form, okay? So we want to get to the y equals mx plus b form, okay? And the reason being, when we want to get to this format right here, then we'll be able to know what the intercept is, okay, the y-intercept. And then from knowing the y-intercept, we can then be able to find out our other y values by using the constant rate of change. So let's do that. So I'm going to change the color again back to the blue. And so first things first, on your paper, you're going to move over the 9x. So we've left with 4y equals negative 9x plus 16. Okay? But that's still not the y equals mx plus b form. So we need to divide both sides by 4. When we do that, we will get y equals, okay, negative 9/4, oopsie, negative 9/4 x plus 4, okay? So remember, all I did was divide the 4 on both sides, on the left-hand side and to all the values on the right-hand side, okay? So now that we're in the y equals mx plus b form, right? Remember, we can know two things here, okay? So first, like I said, when you have it in point-intercept form, okay, we will know the y-intercept, okay, which for us, our y-intercept is whenever our x value is 0, what would be our y value? And that's 4. And then we also know what our constant rate of change is, okay, which is negative 9/4, okay? So now let's use this. So we're going to go over here to the graph. And what we're going to do is first plot 2 points that we know are going to be within this linear relationship. So first, we have 0, 4. Okay, so we have 0.1. And then also, we need another point that goes along with this relationship. And so since we have the constant rate of change, and I know that this is how most of you are going to do the problem, you're going to go down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Because we have negative 9/4, and you're going to go to the right by 4. 1, 2, 3, 4. Okay? Now, something else I want to show you for some of you, if you're not using the method that some use, which is that rise over run, you can also think about this situation, okay? Is that, all right, remember, if we have a linear relationship and we have a constant rate of change, right? Well, please remember, when it comes to constant rate of change, okay? Constant rate of change is m equals, you're used to seeing a change in y, right? Over your change in x, okay? Well, think about it for our situation, okay? You also can notice here that, okay, if I multiply, right? If I multiply this delta x on both sides, okay, that's to get rid of this fraction, I would have delta y, I forgot to put the delta, so we'll have change in y, okay, equals m times delta x. And now please remember, I'm not using anything new. This is something that is already in your textbook as well. So because I have this, okay, because I have this, now also let's look at how this would look on a graph, okay? So I'm going to show you, guess how else this will look on a graph. You're telling me that whatever the change in x is, okay, my change in y is going to be m times as large. Still, if you are confused, I want to show you. So our constant rate of change for this problem, all right, is negative 9/4. So look at this, negative, oopsie. Okay. So when you guys use your graphing calculator, notice what's about to happen, okay? To show that these 2 points are the same. So what if I said x changed from 0 to 4, okay? If x changed from 0 to 4, then my delta x would be 4, right? So we have delta x equals 4, right? So then also think about this. What is, okay? And so now this is the big key part that I hope you guys get at, okay? Whatever the change in my y is, okay, which is this right here, whatever my change in y is, okay, it's going to be equivalent, okay, it's going to be equivalent to negative 9/4 times delta x, which for us, okay, was 4. All right. So now using my graphing calculator or using your graphing calculator, let's see if you can do this before I do. Okay. What would be my answer? Okay. If you did it yourself, hopefully you got the answer negative 9. Okay. So you're telling me that delta y is negative 9. Remember, delta y is a change in y. So my change in y means that, hey, when my change in x is 4, my change in y, right? So when I go from this value, 0, okay, from 0 to some other value, okay, I'm going to have a decrease of 9. And that's technically what we got. 1, 2, 3, 4, 5, 6, 7, 8, 9. We went from 0 to 9. Okay? So this was just a little bit of a way for me to help you make sure that you understand constant rate of change. Okay? But now back to this tutorial of how to use your graphing tool. Once I already have the 2 points, you're going to go over here. Okay, so you see you have 3 different options. Because we're talking about a linear function, that means this linear function is continuous. So we're going to click on this, and we're going to click on the start point, and then another point, which we call the end point. And you're going to then see the graph actually form.